Welcome everyone to this session number 304 morning, and I will continue with a problem that yesterday I tried to resolve, but well, I will start again with this. Let me clean. And I will delete this, and yeah, for example, here is the 6. Okay, now okay, and let me share here in Twitch. Oh, I can share anything here in Twitch. One moment, please. I am checking that if I am online. Okay, got it. Yeah, this is the exercise, and well, yesterday I did an solution, but doesn't works, and maybe, and well, I prefer try to resolve again, starting from 0. And well, the idea is this: you have this problem. This problem say that you have this num course, and this is the prerequisite. Means that, for example, for complete the indicates, yeah, for take this course you should have the course 0 previously. Yeah, this is the previously. Yeah, in this case, for example, for the course 0 don't have any requirement, means that you can take in any moment, but the one depend of the 0. Yeah, and this is the idea. Try to or discover if it's possible finish all the course in other ways return false. It's important here that mention that said all the course, means that if here appear, for example, the number of course, it's 2. Yeah, 2 less 1 is 1, basically. This is the maximum. But for example, here is the 6, but for example, if you have, at least I understand this. If you have, for example, 6 0, and this is the no, let me change here. Yeah, for example, here you have this requirement, and say that if for complete the or for take the course 6, you need to have the course 0. In this case, for example, don't appear the 0 here, means that we can course with any restriction, and basically you can go to 0 to 6, but this doesn't mean that you curse all the curse that appear here, because basically appear 1, 2 and 6. Even in this case should be appear all the numbers 1, 2, 3, 4. It's 0, 1, 2, 3, 4 and 5. Yeah, even here you can notice that appear, for example, the 1, the 2, 3, 4 and 5. Yeah, that is n less 1 is basically this, is 5. Okay, now for this, yesterday I was thinking that a good solution is the first create a map, and in this map, yeah, uh, for example, put in this case the 1 depend of the 0, the 1 depend of the 2, the 3 depend of the 1, the 3 need the 2, the 2 need the 4, the 4 need 5, and 2, 2, 5. Aha, yeah, it's in this way. Now the next that is basically apply a 4 that start in 0 until n less 1. In this case is 6, or in this case 0 minor to n. Yeah, basically is this. Okay, and my idea in this moment is okay, start with the 0 and ask, the 0 has been cursed before? How know that the course has been cursed before? Well, I think that with a sin or with a hash set, where appear that the course that has been checked or has been seen before. Yeah. In this case, for example, if in this case, do you imagine that here is I? I is yeah, here we can use this. I is in seen or has been seen before. In this case, for example, the 0 now the first time is empty. Okay, DFS and the index I. Now in the DFS we can try to get the, in this case, the list for the 0 can be return an empty list. Okay, but in which moment I can mark this in which moment I can mark, or or I should add this value here. Yeah, is when all the course, for example the 0, yeah, appear as a market. Oh, no. Yeah, for example, the 0 return empty, and we need check if this list is all in scene. Yeah, in the case that, or empty, in the case that all the element has seen before, for example, this case is empty, is add. Okay, got it. And this zero don't mark any other. Okay, move to the next. The next is the one. The one has not been visited before. Return the 0 and the 2. Yeah, this return 0 and 2. Okay, now the 0 has been as a market. Okay, just remove it. Well, just ignore. The next is the 2, and the 2 is basically another DFS that return the 4 and 5. One moment, please. Okay, now let me think again, because I don't feel that I am in the right path, in the right way. For example, for mark that this one has been complete, I need to have these values in scene. And for add the value in scene, I need to validate that all elements in the list has been visited before, or has been seen before. For example, the 0, the value is it's an empty list, yeah. we can validate, okay, it's an empty, only add. Got it. Now move to the next. The next is the 1. Okay, now the 1 return, in this case, 0 and 2. The 0 has been visited before, yeah. Now the 2, and the 2 start another process that return 4 and 5, yeah, and start here, and the 4 have the number 5, yeah, and here the 5 4 2 1, yeah. The 1 is this, and this, yeah, and they return this. Okay, now this is empty. I can mark the 5 as a sin, and these have all the elements that is only 1 complete. Okay, I can mark this that it's complete, come back, yeah, and say, okay, the 4 is complete. Now the 5 is complete too, yeah. Okay, I can add the 2 and come back to the 0 is complete. Okay, now the 2 has been complete before, yeah. Now it's the 1. Okay, and we can complete this with the 1. Okay, now the 2 has been checked before, yeah. Now the 3 has been visited before, no. Okay, the 3 have the 1 and the 2. The 1 appear here, yeah, is ignored. The 2 appear here, yeah, is ignored. And basically we can add in 0 1 2 3 4 5. Okay, now what is Twitch here? Okay, now this is the idea. For this, I only need to validate that all the elements, for example, all the elements of the 1 has been visited before, yeah. And how can I know that? Basically, but what happened, for example, with the 1 that depend, no, depend of the the 1 depend of the 0 and depend of the, yeah, here, for example, 5 depend of the 1 and 1 depend of the 5. It's a cycle, yeah, it's a cycle. Here, for example, the 1 have 0 and 5. The 0 was added before, okay. Now the 5 sorry, return the 1, and the 1 return the 5. We are moving only between both. I think that it's necessary have a scene for avoid another scene for avoid this operation, because, for example, I'm not sure if it's clear what is happening here, but if you have, for example, the 0 is marked as a sin, okay, whatever. Now the 1 need, for take the 1, you should have complete the course 0 that it's here, and the 5, okay, the 0 is ignored. Now the 5 need the 1, yeah, but the 1 again called the 5. And basically with this we have a big problem because it's a cycle. Now for break or for avoid this operation, I think that we need to send in the DFS function the another um, another set, sorry, with the values that has been processed, not seen, process, only process. Yeah, for example, the DFS receive the number or the course and receive the set. And basically it's okay. The first that if set contains n, return only stop. Yeah, this case, for example, if this is 1 and the set is the set the first time is 0 and is not add, set don't contains, no, okay, we can add set add n. For example, now the set contains the 0 and we need ask if, well, the validation, get the values of 0. When it's empty, it's only add here in the scene and that's it. Okay, now to the next, basically start, but now with the 1. Yeah, and this is a new set. Set contains the 1, no, okay, add the 1 here and start with the 4, where you need to get the values of 1 in the course that I need, for example this. Okay, the first has been checked before. Yeah, okay, now the next that is the 5, and the 5 start another operation where in this operation is, for example, 5, but with the previous is 1, and 1 is okay, is return. Yeah, the problem is this. How can I avoid this cycle? You start with the 0, well, the 0 doesn't matter in this case, the 1 have the 0 and the 5, the 0 is ignored, and the next is the 5, that the 5 have the 1, but the 1 is currently checked. Yeah, we need handle this case, but okay. Yeah, I think that is with start with the 0, now it's with the 1. The 1 have 0 and 5. The 0 is ignored. Now the 5. The 5 return the 1, but the 1 is in this value. Okay, and this is not complete. This not execute, and if this structure don't have you have the 1 and the 1 have the 0 and the 5. Okay, now you start with the first has been visited before. Yeah, oh yeah, it's marked courses. Yeah, well, this mark as a complete. Now the next step is the 5, and the idea is how can I know that this 5 is marked as a complete, because we need to go to this and this return only 1. In this case the 1 is complete. Yeah, I think that with these structures to receive the value, yeah, the DFS receive the number of course, and the the current course that is processed. In this case, if n is not in hash, no, is in hash, return the case hash dot add n, yeah, and the for blah 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 blah. Yeah, for example, in this case receive the 1 and have the 0 and 5. Okay, 0 is ignored because has been complete, and the 5. Okay, now this 5 receive, well, have the value 1 and have the hash with the value of 1. Okay, in this case if return, this never is add. In which moment I can add this course, because yeah, I think that we can try with this approach, count or validate if the all elements appear in the here, for example, and let me copy this here. Okay, and okay, now the next that is create an hash set it's equal new hash set. Obviously it's an integers. Yeah, and the next that it's a hash map integer a list. In this list integer it's map it's equal to hash map. Yeah, and next two is 4, but this 4 is integer in array requisites. Yeah, and next two is if map dot contains key array in the index 0, map dot put it's only basically for initialize the elements. New array list, yeah, and here is map.put. After this operation, we are sure that all the time we have at least the record in the map, you know. Array in the index 0, and no, this is get because we are getting the list, and dot add array in the index 1. Yeah, okay, got it. With this we are full. Now the next step is the for, that this for is integer I, it's equal 0, and void I, it's minor, come on, it's minor to num course I plus plus. Yeah, next to is dfes, and receive the e. And now here I need to create another structure, but here emit scene, yeah, and initialize here. Okay, and basically is if scene contains I but negative is not contained, okay, is put the dfes, and the final is if the scene dot size it's equal to the num course, means that have complete all the elements. Yeah, now the primary function here is the private void dfes, yeah, in this case is even this dfes could return a boolean, yeah, maybe we return a boolean, and this receive integer n, and basically if all the elements has been checked for this course, you can return true, and yeah, for example, for here is integer I it's equal 0, while I it's minor to command integer here is course, and here is integer n is map dot get or default. Why get or default of the course? One moment. New array list, yeah. What get or default? Because for example here doesn't exist the 0, yeah, means that doesn't exist the record here. It's only return the empty list. But one moment, here I need to create this hash map outside of this function, yeah. Sorry, and is basically here, and if for example, do you imagine that the course is the 1, and the 1 depend of the 0 and 5, yeah. The first that is scene contains is not contained the index n or the course n, we can apply the DFS, resize the n, you know. And okay, now in which moment we should add this course, or yeah, in which moment we can mark this course as a complete course, where all the values doesn't, well, all the values appear in the, yeah, if here, I'm not sure how compare with a counter. Yeah, it's not necessary validate too much, it's only counter index, it's equal 0. Yeah, and here is basically else I plus plus has not been, no, this is wrong. I need to validate that all the values that appear here, first if, maybe this I can create a list here, list integer requirement, no, yeah, the prerequisites of the this is basically this element. If is empty, okay, I can add to the scene dot add and add the course and return, yeah, stop. Okay, if this doesn't happen, okay, basically we need for each all the requisites and say that, and next to is here we need another for to validate that all the course, in this case integer x double point prerequisites, if scene contains only with one, it doesn't contains, return false. Okay, in other case return true. Yeah, in this here, okay, for example, to receive the course 0, the course 0 return an empty list and is only add to scene and it's complete, stop it. Okay, now the scene here contain the 0. Okay, move to the next is the 1. The 1 is not in the scene, no, okay, it received here 1 and this return, for example, the 1 the one for the 1 is this and only that. Here receive these numbers, okay, the list is empty, no sir, and is okay, go to the prerequisites, the 1, return the 1 and the 1, yeah, it's only that the 1 need the 0. Okay, the requirement is 0. Okay, the 0 has been visited before, yeah, and in this case is validate, it's only the 0. The 0 never is true here because it's contained and return true. Okay, is wrong here. In which moment I add this value in the scene if dfs return true, scene dot add n. Yeah, okay. The 0 is empty, okay, it's only add and that's it. Now receive the 1, the 1 required is 0. Okay, this is not execute because it's not empty. Let me delete this. Okay, start with the 0, this is no, it's necessary. Okay, now receive the 0 is add and is stop, and that's it. Now it's 0. Now the next step is 1. Please receive the 1. The 1 need depend of the 0. This is an empty. No. Okay. Now here it's necessary the 0. The 0 has been visited before. Yeah. Okay, and it's a stop. Now the next step is here. That is 0. Is not contained. In this case never cross because it's contained, and return true means that for this, for the 1, return true, and we can add this as a scene. Yeah. Now the next dot is the number 2. Okay, 2 has been visited before. No. Okay, cross here. Now the 2. Yeah, 2 and 4, and 2 and 5. Yeah. Is an empty? No. The rest of the 2. And this course 2 depend of the 4 and depend of the 5. Yeah. And yeah, 2 depend of the 4 and the 5. Okay. Now 4 has been visited before. No, because currently we have only the 0 and 1. Okay, cross. Now here this DFS is the 4, and start again here in 4. Yeah. This 4 we can validate what is the result of the 4. It's only is this. Yeah, the 5. Okay, it's empty. No. Okay, here receive the 5. The 5 has been visited before. No. Okay, now I will send the 5, and here receive the 5, and the 5 depend of the anyone. Okay, this return yeah, it's add the 5 as a scene because don't have elements. It's empty. It's marked is return. Here return true, and it's add the 5. Okay, has been put before, but okay, it's 5. It's okay. It's complete. And we are iteration. The 5 is complete. Now come back to the 4. The 4. Yeah, it's only the 5. Yeah, it's complete this, and basically here is only return 1. The 4 depend only the 5. Yeah, here 5 crossing one moment here. No, because it's contained. Return true means that the 4 has been complete. Only the 4. Okay, the 4 is add to the list. And now the that is 5, 5 is not contained, no, because it's contained, and here is basically validate the 4 and the 5 appear here. Yeah, return true. Okay, and is add here to the 4, and the 2 is complete. Yeah, I think that no course it return. What? What? It's an integer. Integer any. Ah. Okay. Ah, come on, again integers. Let me check before to execute the code. This has not been necessary in this moment. Yeah, now here is necessary. Yeah, here, yeah, it's necessary the same, because all the time, yeah, this is necessary, because in other way we don't have the idea or the tech if the value, yeah, detect the cycles inside them. Here is if set dot contains course means that is in process, return false for stop it. Yeah, and next to is another way, set dot add course, and here is a new one, new hash set. Come on. Okay, and I don't need this. It's only this hash set, and here the set is add to here. No, here. Mm. Well, I think that it's not too easy, this problem. Okay, cycle detection and direct grab work different. Mm. This is a very good tip. In this case, for example, it's not equals to this, is equal to the map dot size. Yeah, because in this, for example, the number course is 3, but only have the 0 and 1, don't have the 2. Yeah, okay, this is the 1 point. And oh damn, why return false? Well, at least works the detection of the cycles, but what happened with this? Why return false? Okay, let me check only the scene. Mm. System.out.print line scene. I'm not sure if it works with only this. No. I really want to see the content of the set. See. Ah, it's not the set, it's the okay. Now let me check. 0 1 2 4 5. What? Why the 3 is not okay? This is interesting. Why the 3 don't appear here? Let me clean this. Here. Yeah, this is the problem. The 0 don't appear, okay. The 0 1 2, the 3 why don't appear? The 0, the 1 depend on the 0, okay, the 1 is yeah, maybe here has not been. The first is that if map.contains key, maybe only add if here is seen dot add. Yeah, it's not necessary to move, it's only add and continue with the next. What? He's here. Oh, sorry, it's not contained. Wow, what is the 0 1 2 4 and 5, and why the 3 is never. No, this is wrong. Okay, I need to check what is happening with this. Okay, I can delete this because it's not important in this part. Yeah, here it's remove it. And this is wrong because if the 0 doesn't appear, this is wrong. Yeah, this 0 is wrong because, for example, here appear the 0, but 0 never appear here, and these have the value 0 1 3 2 4, and don't have the 0 and don't have the. Okay, this is the first point. This is wrong, means that we need for each the map, and if one element in the map is not present in the scene, I need return false. In other ways, if all the values in the map is contained in the scene, I can return true. Okay, now why don't appear the 3? Okay, the first time. Okay, let me check what is happening here. Yeah, we have this, and basically this. Yeah, the 1 depend of the 0, the 1 depend of the 2. Yeah, the 3 depend of the 1, depend of the 2, the 2 depend of the 4, the 4 depend of the 5, and the 2 depend of the 5 too. Okay, now here this is our map. Okay, now the first that is we have here start with the 0. This is wrong. This should be only to the map. This can change to the map. For example, the map have but we don't know what is the. No, yeah, it's okay. This until the final num course. Okay, whatever. The first time scene is here. Okay, this is our scene. Scene contains the 0. No, okay, go to the DFS with the course 0. This is an empty. Set contains the course 0. No, sir. Okay, we can add the 0 here. and next to is return the values of the 0, that in this case is an empty. The results are empty. Yeah, okay, we can add to the scene. The 0 has marked as a scene and return true. Okay, here return true, but it doesn't matter. Okay, got it. Now move to the next. The next is the number 1. The number 1 has been visited or has been seen before. No, okay, we can add the 1. We can add the 1 to receive the 1, and this is a new empty set. Okay, set contains the number 1. No, or is processing the 1. No, yet is in process, you know. This is not execute. Add is 1 here, and next to is okay. I need 2 values for the 1 that is 0 and 2. Okay, this list is empty. No, it's not execute this. And next to is okay, let me these values. I need these values. I need these values here. Okay, now is seen, sorry, 0 has been seen before. Yeah, okay, it's only ignore. Next to is seen contains the number 2. No, okay, we can start with the 2, and here receive the 2 with the set 1. Okay, now yeah, this is basically here. Okay, now set contains the course 2. No, not yet, only 1. Okay, we can add here, and okay, I need the values of this course. In this case is 4, only 4, and is empty. No, okay, now for the 4, 4 has been visited before. No, because we only have the 1. Okay, we can add in the DFS the 4 and the set with the 1 and 2. Okay, now the 4 with the 1 and 2 is received here, and set contains the course 4. No, it's only contains the value 1 and 2. Okay, we can add, and is 4. Why 5 and 5 appear here? 4 depend of the 5. This one, only the 5. And sorry, we are here. This please, I need the values that depend of the 4. In this case, only return the number 5. Okay, is empty. No, okay, here is only the number 5. The number 5 has been visited before. No, okay, send the number 5 with these values. Okay, here receive the 5 with the 1, 2, and 4. The 5 is in this list. No, okay, we can add here the 5. Okay, here is I need to get the prerequisites of the number 5. It is return empty. Okay, is add as a scene or market, yeah, and return true. Now basically this is complete, and this was executed for the 4. Yeah, in this case, for example, okay, the 4 has been marked as a complete. We can add here, yeah, and now the 4 is complete too. Come on. Okay. I think it's better this. Okay. Now the 4 is complete and is add. Okay. Now the 4 has been called for the 2. The 2 is complete and return, okay, here. And the 2 has been called for the 1 that is complete 2. Okay, the 2. And okay, now here okay, now the next that is the 2. Now in this moment, where here has been visited before. The 1, yeah, the 2, yeah, the 3. Okay, here appear the 3. The 3 is contained in the scene, no, because it's empty. Yeah, it's empty. Okay, it's marked as a current. Okay, the 3 return the 1 and 2. It's empty, no. Has been visited. Is for this. Has been visited. The 1 and 2. The 1, yeah, the 1 should be appear here. Yeah. Okay, yeah, here it's only add if this scene.add the letter I. In here it's return true, but I need validate before that for integer n double point scene, no, map dot get key set, yeah, for each keys hash map. Okay, I remember one way to very simple. It's only with this way. No, I only want to use the keys. It doesn't matter the. I remember that no Java 8. No. Okay, well, whatever. Here is basically here as map. Yeah, in this map is if scene contains but negative. If it's not contains entry dot get key, basically return false because has not been visited. Entry set command here is an list of integer, and here it's another integer. Well, I'm not sure if it's done. Let me check another. Okay, this is a good comment because please one test here. Okay, we have this. Now the next, I think that is here, right? Here, no. Okay, this one's great. Here, and it's 10. think? I will get success or not? Ah, yeah, it's 10. This should be 9. Consistent value to 0. What? Ah, it's a wrong test. Multiple cases. Okay. 5. Disconnect components in a cycle. Okay, and I think that this is the last. Okay, I think that it's done, but yeah, it's very bad performance. But let me publish here, and I will try to improve. This is my first try. Yeah, obviously it's not the best. Yeah, I can improve, but solution using grep TFS, and here is Java. It's better to have a ugly solution that don't have any solution. But well, okay. I am in the last position here. Okay. Yeah, it's not a good. Okay, now let me check my code here. Okay. Okay, has seen. The first I can join this. Yeah. And okay. No. What is the description? Here. Discussion. I want a few tests here for this no cycling dependency tree. Next to is this multiply. Here. Now the next is this. And yeah, this why not? Oh yeah, sure. Okay, yeah, it's a little thing, but well, let me check how can I improve, because it works, but I have a very bad performance. Okay, course. I think that I can improve this section. Uh, Here, because I am applying many operations at the same time. Okay, let me delete this, delete this. Now, for example, when you have what is the case here, you receive the 0 depend of the 1. Okay, here receive the 0 and this is empty. The 0 was previously processed. No. Okay, you can add and get the requirements of this course is only the 1. Is an empty. No. It's possible check hash set contains only received an object or can receive a list. Contain method used to check whatever specific element is present in the hash. So basically, it's check if the set contains a particular element. The parameter, so the need to test it, blah blah blah. Hash set, it's the same article. Contains all. Contains object. Contains specific element. True. Yeah, but I need know if it's possible. What? I need know if it's possible to check if one list is contained in a set without applying the loop. Check if an array exists. At all, okay, no. Contains methods. Digits, chat. No, but in all the case only compare one element, but I'm trying to check if it's possible, because in this case where all the elements has been visited before, it's not necessary continue, but hash set contains all elements in a list. Contains all. Okay. I think that is a function. Contains all. It's Java. Yeah. Simple connection. Blah 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 blah. The set 1. Yeah. This love. The set 2. Contains all. I think that we can try. Or scene.contains, and in this case is basically this. This is for avoid the operation. Okay, improve. and now here is the same. Here even I can return only that sync contain all prerequisites. No, prerequisites sync. What? No, this is in negative. Wrong answer. What? Prerequisites. Sync contains. Contain X is not contain it. Hello, I love coding. Hello, I coding. What happened when? Oh, come on. When it's in a different order. Oh, use hashtag doesn't contains all. Okay, I think that it's with this and is similar here. And but I need to return this. Okay, or return true. Oh, okay. I will send and check what is. Oh, I still in the same. Yeah, I think that only this contains all is basically check one by one, but. How can I improve? Now, another possible approach is that for each the number course that 0 to n and put this value and another for that for each these prerequisites and only have or add this value and execute this and say that scene contains the 0. In this case, for example, we can take this. Okay, the 0 don't appear. Okay, is at here in DFS with the new hash set. This hash set is used for detect the cycles in the graph. And now we add this. Here is add prerequisites. Yeah, return the value when it's empty or all the values are contained. Return true. In other case, the prerequisites is not contained. I will check the question because I don't have more ideas. The project has so. Okay, I don't know this approach, but I think that is much better than mine. Okay, let me check before the other solution. DFS. Okay, course, prerequisites. Okay, the list of the course. Oh, okay, we have the here. Don't use the map. Use a list of the list. And okay, prerequisites. It's the prerequisites in the index 1. Only is fill the elements. Okay, visit and stack. Defeat receive the I. ATG. What is ATG? Is the list. Can finish. Okay, I need copy this. Okay. What is the mainly? Yeah, this course. Okay, we fill. Basically, this is a map. Only that. Visit. It's equal new boolean. Course. The stack with the num course. Okay. DFS, and we pass the current course, the map, visit, and is stack, and what have the DFS here. Receive the map, the visit, the stack. The stack is in the node. Basically, with this, we can note that. Yeah, why return true? Okay, got it. Visit node has been visited before. Okay, here in my solution, oh my god, what is me? My solution is here, is this. In my solution, I received the course and the set, and yeah, even I can improve this. Only pass or add the if the course has been seen before, only return true. No, but in which moment? Okay, let me continue check. Okay, we mark it as a node. In DFS and still moving. Can finish. DFS. Let me check another solutions. Yeah, it's too slow here. Okay. In this case, here, DFS mark as a node. Okay, let me copy my. Okay, here. Set contains the course. If scene contains course, true. The problem here is that all the time I am trying to verify many times the problem, because if I send yeah, I still in the last. Here use the in the stack. Here remove the last, return false. Okay, I noticed that avoid all the time, return true here. Oh, no, is yeah, here. It is the 4, this. I need improve this function, because for example receive the 0 is contained in the set, that means is previously processed. No, sim contains the course. This is never will be executed here. Set add. Prerequisites. This is I need return of the set. Well, I will check more late.